Hey guys, so here's the notes for 4.6 day 2. We are going to identify complex numbers and be able to solve quadratic equations that involve complex solutions. So we kind of talked about the idea of imaginary numbers, I. So what are complex numbers? Well, basically they are all numbers in the entire world, okay? So we have our big complex numbers that involves every single number in the entire world. And then we talk about real numbers. So real numbers are a part of complex numbers. So these could be like, we got 1, -2, 0. They can also involve like rational. So rational are when we have values that terminate. So that could be 1, -2, 0, 1/2. Okay. They can also involve numbers that are irrational. So numbers that don't terminate, or meaning that they go on forever. So meaning like square root of 2 and pi, okay? Now, then we have imaginary numbers, which you guys just learned in 4.6 day 1. So this is basically like square root of -5i. We have -3i, okay? And the complex is where you have basically real numbers and imaginary numbers together. So this could be something like 4 minus 3i or 2 plus I, okay? So now we're going to be seeing more of complex numbers where we are combining the real with the imaginary. Now when we do complex numbers, we're going to see A, which A is the real, and then we have BI, which is the imaginary, okay? Now anytime we are going to have complex solutions, we need to make sure we write in standard form. And that is going to be of the form of A plus BI. So your real value is first, and then you have your imaginary value. Okay, so now we're going to include all that for adding, subtracting, and multiplying our values here. So adding and subtracting, basically this is very similar to if we were adding and subtracting anything with a variable. We are going to combine like terms. So let's look at example 1 here. We have 8 minus I plus 5 plus 4i. So the real numbers we are going to combine, so I combine my 8 and my 5. When I do that, I get 13. Then I'm going to combine my imaginary numbers, which is going to be -I and 4i. So when I do -I plus 4i, that's going to give me a plus 3i. So my final solution, which is a complex solution, is 13 plus 3i. And please do not forget, when you are adding, subtracting, multiplying, and later we'll get into dividing, you always need to make sure we write in standard form. Okay, let's look at number 2. Now we are subtracting. Now be careful when we subtract, because we need to distribute that negative to everything that is behind it. So basically everything in the parentheses. So I'm going to do that and rewrite this, so then I can combine my terms. So I now have 7 minus 6i, so that stays exactly the same. But when I distribute the negative to the 3, I have now minus 3. And when I distribute the negative to the -6i, that is now plus 6i. I now combine my like terms. So I have 7 and -3. That gives me 4. And notice with the -6i plus 6i, they cancel out. So my final answer is just 4. Okay, pause the video and try number 3. Okay, let's see what you got. So don't forget, distribute. We do have a subtraction sign, so we need to distribute that to both the -2 and -7i. I'm going to rewrite, so I have -4 plus 6i. 2 negatives make a positive, so I have plus 2. And same thing for the 7i, I now have plus 7i. Please do not forget to distribute that negative. Okay, combine like terms. I combine my real numbers, which in this case is -4 and 2. That gives me -2. Be careful with your signs there. And then my imaginary numbers, which are 6i and 7i, which gives me plus 13i. And notice that we did write this in standard form. We have our A, which is the real number, and then our imaginary solution. Okay, make sure you watch the next video. That's going to be over multiplying. So we're going to do something very similar when we do our multiplication.